No sugarcoating, no spin. Taking failure so you can succeed. This is the Failosophy audio and video.
In the time of chimpanzees, I was a monkey. Butane in my veins and a mouth that kept the junkie.
Hello, everybody. Welcome to the Failosophy audio and video cast. I'm your host, Gabe Zichermann. Before we go any further, I want to apologize. We originally were going to have Amy Jo, the amazing Amy Jo Kim, on the podcast today. And unfortunately, we've had some technical issues with Skype. And for any of you who've ever used Skype, this comes as zero surprise to you, I'm sure, that Skype is just not working, not working fast enough, not working well enough to make all of this actually happen. So, sad face, but Amy Jo is committed to coming back on the podcast. We're going to work through the technical issues and have her back maybe as soon as next week. I will update you all on social media. Thank you for thank you for your patience as we're frantically trying to get this thing working today. So, so unfortunately that didn't happen. But if you want to stick around for a minute, I want to talk about something today that I think is, on a lot of people's minds in the world a lot, which is about, a particular failure situation that most people in the world are aware of. And that is, the crash of the Boeing 737 MAX. And many of you may know, I'm not going to spend a ton of time recounting the facts of the case, but I do want to share my own particular perspective on it from a failure management and a Failosophy standpoint. So many of you know there have been two fatal crashes of Boeing 737 MAX 8, one of Lion Air in Indonesia, one of Ethiopian. Now all attention has kind of been focused on a software glitch, a problem with the plane. But the software glitch issue related to the maneuverability and control systems of the plane doesn't really tell the whole story. And so I just want to take a step back. I did a detailed failure analysis on this, which you can find at failosophy.com if you want to take a look at it to really understand how this works and what's happened. But basically, here's the summary. In order to make this plane work, so airlines, wanted a more efficient version of the 737, which is the most popular narrow-body aircraft. So airlines wanted a more efficient version of the 737 MAX, but did not want to have to pay to retrain pilots on a new version. So in order to accomplish those two things, Boeing took an old design. The 737's original design is around 40 years old. Boeing took an old design and added a new set. They did a bunch of things to it, changed the wing, changed the fuselage a little bit. But the main thing that's different is they added a new kind of engine, a special kind of engine which delivers the majority of the efficiency benefits that the airlines had been asking for. Most of that's in the engine. But it turns out that the engine has a different shape and a different weight and changes the aerodynamics of the aircraft in such a way that in order to meet the requirement of not certifying a brand new plane and not having to retrain all the pilots, what Boeing did was mounted this engine on this aircraft, changing the fundamental way that the aircraft flies. So by putting this engine on the plane flies in a different way from the way that pilots would expect it to fly. That doesn't mean it can't fly. That doesn't mean it's not stable. It just means that under certain conditions, under particular operating conditions of this aircraft, it does not fly as expected. So new safety risks are introduced as a result of that. And typically that would just require some retraining on the part of the pilots. But in order to avoid the retraining, what Boeing did was they wrote a piece of software. And that piece of software's job was effectively to mask the change in the aerodynamics of the aircraft so that it would perform as expected in all the conditions. Basically, it's like taking an old operating system, a really crappy old operating system, and putting a brand new layer on top of it that makes it look all fast and new, but in the background, all this stuff is happening to facilitate the that transition to the older operating system. So Boeing implemented this piece of software, which is called MCAS. Didn't tell anybody about it. That was one of the mistakes that they made. Didn't tell the pilots about it. Didn't tell so many pilots just didn't even know that this feature was there. And the idea was that the MCAS would, under the circumstances where there might be an aerodynamic problem with the aircraft, it would intervene and using software ensure that the airplane didn't stall. And a stall is, a very dangerous situation for a plane. It can cause it to fall out of the sky. So this software was designed to compensate for that. So just so we're all on the same page, where we're at right now is Boeing made a fundamentally problematic engineering decision, a core mistake, okay, which was to not design a new plane from scratch if they wanted to use this engine. So the first questionable decision is putting this new engine on an old airframe where it's not aerodynamically efficient. And then to cover up for or fix that mistake, Boeing wrote a piece of software called MCAS. So MCAS is a fix for a mistake of Boeing's original engineering strategy. So now you have this particular situation. Now it turns out that software has bugs, software has flaws, software often fails. And in order to deal with those kinds of bugs and flaws in software, typically we have, especially in aviation, we have a lot of redundant systems. That means is there's multiple inputs are measured so that if there's a failure of one particular instrument, the whole flight does not become dangerous. This redundancy has been part of aviation safety for a really long time. So this particular piece of software uses these two sensors on the front of the plane and for whatever reason doesn't do a redundancy check. It just looks at one of the sensors. And if it gets the input that it wants, and this is like a software failure. This is a mistake of how the software was engineered. If it doesn't get the result that it's expecting, then it initiates this session. And it doesn't tell the pilots that it's doing it. So the pilots are not trained. They don't know what this is. It's being driven potentially by erroneous information. And now it puts the plane in a dangerous situation from which the pilots may not be able to recover. And then this doesn't come to light. So this angle of attack sensor problem with MCAS doesn't come to light until after the first Lion Air crash. That was the crash last year of the first 737 MAX. It doesn't come to light until then. And then Boeing's fix for this problem, the fix that they offered, if you can imagine, the fix that they offered their airline partners was to give them a warning light. And so that warning light would say, the angle of attack sensors, the two sensors, have a disagreeing value. And that is their solution. So just so we're all on the same page, incorrectly engineered aircraft from the very beginning. So made an engineering mistake. Attempted to cover up that engineering mistake by writing software, which is already very unusual in commercial aviation. This does happen in military aviation. There are a lot of fighter jets that are not stable at every phase of flight. And so software is required in order to ensure that a fighter jet that's really good at Mach 2 is also stable at lower speeds. But pilots are trained for that. And we typically do not do that in commercial aviation because it raises the risk of potential crashes. So we've got a fundamental engineering mistake. That engineering mistake is covered up by software. And again, a mistake is made by not training people, not explaining how this works and so on, just kind of trusting in the software. Then there's a mistake in the software because it's designed to use the wrong inputs incorrectly for the mission that's called for. And of course, software has lots of mistakes. And so as a proposal to cover up for that mistake, Boeing offers to make a warning light, which, by the way, customers were expected to pay for. So that was the thing that airlines had to pay for out of pocket. So it's a warning light to cover up for some bad software, which is designed to cover up for pilot training, which is designed to cover up for a fundamentally questionable engineering decision. Anywhere along the way, at any point in this cycle, if Boeing had been able to accept failure, if they'd been able to say, you know what, we made a mistake, there's something wrong here, we need to change course, let's admit this mistake, as expensive as it will be, let's stop the production process, let's re-engineer this plane. If we need to go back to the very beginning and redesign the plane from scratch, let's do it. Instead of doing that at any point along this process, they could have done that, at any point. Instead, they covered one mistake with another mistake, with another mistake, with another mistake, and eventually it cost the lives of 2 plane loads of people. It's cost Boeing more than $25 billion in market cap. That $25 billion number is the upper limit of what it would have cost to design a brand new plane from scratch. This calculation was one of potentially the worst cost-benefit analyses that any company has ever undertaken in history. This is literally like just a mind-blowing thing. And so you say to yourself, okay, look, it's really easy to blame Boeing management, blame airline executives. Everyone's greedy. Nobody wants to do the work. Everybody's like pushing really hard. But Boeing is a phenomenal engineering organization. I mean, they are one of, if not they're one of the world's most capable and best run engineering organizations. It is unusual for a company with those kinds of chops, with that history and that experience, and a public company with all these stakeholders and everything, for that organization to have gotten to this point in the cycle where they, where they covered up one thing, A, B, C, D, all these failures along the way. I don't think the profit motive alone explains that. I think that is a fairly surface analysis. It's what most of the media has reported on. They've talked about how, Boeing was really pushed very hard to do this, and treating it as a cover-up. But I actually don't think that that's what's going on at all. I think what's happened is a fundamental cultural problem with accepting failure, embracing failure as a core part of the schema. So if you think about how aviation engineering works, all the testing and research is typically front-end loaded. So these companies will spend years and years and years and billions of dollars building models, hiring, huge teams of engineers. They're going over every possible scenario, every possible thing, so that by the time the aircraft first flies, the very first maiden flight of the aircraft, typically there are not major technical or design problems with those planes. It used to be that when you test flew a new plane back in the 50s or back in the 60s, there's a pretty good chance you would crash because those planes had all kinds of new ideas in them that hadn't been fully tested. And so what the industry did was they really front-loaded that. So years and years, billions of dollars, hundreds of thousands of person hours of labor go into the upfront engineering. And this is what in software we would call a waterfall engineering process, which means there's all this effort put in, there's whatever, kind of background testing we're doing on it, and then all of a sudden we dump it into the world and expect that product is going to work. And in this particular case, waterfall engineering was not what was called for in the process. An agile approach is what was called for in the process. And that is making small changes and then testing those changes in real life, testing them with customers, testing them in situ, and making sure that those little changes actually advance the cause of the core product and are getting the kind of customer buy-in and the kind of performance that the customers actually want. And so you have this organization that, because it's so good at engineering, because it's been doing these very complicated projects in this waterfall fashion, this organization just did not know how to admit failure. From engineering all the way up to senior management at Boeing, anybody could have raised their hand and said, there are fundamental problems with this product. This product is fundamentally broken and we cannot band-aid it anymore. We must back up and do some fundamental rethinking about this product. And that would have cost a lot of money. They would have had to delay orders. They might have had to renegotiate orders. They might have needed to design a new plane from scratch. I don't know. I don't know what the correct ultimate system is. But what I do know is that by not being able to accept failure at any point in the schema, not being able to look at themselves and say, hey, we're doing something wrong. This isn't right. This approach is not working, rather than this approach is working with this Band-Aid. By not being able to say that, that costs the lives of a lot of people, costs a lot of market cap, it's cost a lot of reputational harm to Boeing. And all of these things at their root are failure, about not being able to accept failure. And I think we need to take a step back when we think about big engineering projects. And we need to say, look, no big engineering project can take place without the potential risk of failure. Look at the Transbay Terminal in San Francisco, for example, which is a big multi-billion-dollar project to build a new transit terminal in the center of San Francisco. It is having all kinds of structural problems, cracking beams, weird things are showing up. This was a really expensive, really big project that inconvenienced millions of people over the last 10 years that they've been working on the project. And once those problems became evident, the Transpay partnership paused the availability of the center. It's closed the parts that are problematic, and they are re-engineering them in order to ensure that they do not have that problem anymore. They're not putting up a sign that says, warning, this pedestrian overpass bridge might collapse, which is what Boeing is basically doing in their design. They're actually backed up and they've said, there's a mistake, we have a problem, we need to fix this problem. And that basic premise, and you understand that people will suffer for that, market cap will suffer, deliveries will suffer, customers will be upset. But there's never a scenario, especially when people's lives are at stake, especially when their health and welfare are at stake, there's never a scenario in which not accepting failure, not being able to embrace failure, produces a superior result. That's never happened before. Eventually, everything comes out. Eventually, the causes are identified. Eventually, you get to the root of it, and you find, what could be charitably described as overly optimistic engineering, and less charitably described as, pure malfeasance. And so I think this Boeing example is a very good illustration. I think the Transpay terminal is another illustration of how to handle that differently. And my, basic advocacy position, I think, for all of you out there that run organizations that are responsible for, complicated, difficult, new, innovative engineering challenges, I think the core lesson of the Boeing experiment with the 737 MAX is that you need to be transparent about your failures. And at any point in time, anyone on the team should be able to say, hey, wait a minute, this isn't working. We've got a real problem, and we need to rethink this and we need to reset it. Trust me, it's never worth going ahead with your Band-Aid solution. So that's my kind of thoughts about the Boeing 737 MAX. I welcome your thoughts and inputs. You can read my long form analysis of this at failosophy.com. And of course, if you're a regular viewer of the podcast or listener of the podcast, be sure to subscribe to the Failosophy podcast wherever you get your podcast. We try to be, try to deliver these on a regular basis. And of course, we weren't able to have Amy Jo on today, but I love her. She's one of my favorite, most brilliant people that I know. And so I'm super excited to have her back. I've been your host, Gabe Zichermann, of course. You can follow me on Twitter at gzicherm, and you can follow Failosophy on most platforms, Twitter, Facebook, Instagram, at The Failosophy on your favorite platforms. So thanks again, and we'll see you guys next week.
If you enjoyed this episode, click subscribe, leave a review, share with your friends, and come back next week for more real talk about failure. And remember, if you're not on the precipice of failure right now, you're not living to your full potential. This has been Failosophy with Gabe Zichermann.
So why don't you kill me?